preview of what you're about to build. Your first circuit will supply power to an output. You'll connect an LED to a power source and that LED is going to light up. Although this is a simple circuit to build, you must understand the connections of the breadboard to successfully power the LED. This circuit will open your mind to visualizing the connections inside your breadboard. By understanding the connections of the breadboard, you can begin designing your own circuits. Remember, the breadboard is like the canvas, and you paint your circuit on the surface. For this project, there is no programming, so there's no need to boot the Pi. So actually, I like to remove the SD card so that when I plug in the Pi, it doesn't try to boot up. So it's spring-loaded, I just push down and then pull the SD card out. So without the SD card, the Pi is basically a giant battery, and I just plug this in. This is my power cord. I plug it into the side, and whatever circuit I have built will receive power until I unplug the Pi. Here I have all the parts I need to build this project. I have my breadboard, some wire, the red LEDs, the 470 ohm resistors, and the T-cobbler. My breadboard is positioned so that row 1 is at the top. You should do the same. We consider this sort of like portrait mode versus landscape mode when we turn it 90 degrees. Now I'm going to attach the T-cobbler, and I'm going to position it so that pin 3V3 lands in row 3. So I pick this up, and again, I'm lining this up so that 3V3 is in row 3, and actually, it's going to rest slightly further to the left. So I actually have basically 2 dots visible to the left of the T-cobbler, and 3 to the right. Once I have it lined up, I'm going to push it all the way down into the board. As you saw, I did have to work to press it down into the board. The first time you install it can be the hardest. I'm going to place a wire to connect the 3V3 pin to the positive rail. Now I'm actually going to grab a gray wire. It doesn't really matter the color. So grab whatever color wire you have that's the right length. So this wire actually lands in row 3. It connects the 3.3 volt pin, 3V3, to the positive rail. Now I'm going to attach a wire that connects the GND ground pin on the right side of the cobbler to the negative rail. This connects row 19 to the negative rail. Now I'm ready to attach my first resistor. I want to put on my safety glasses because I'm going to actually be clipping the legs of this resistor. Also, I've rolled up a piece of tape and I'm going to push it down here on my table. And as I cut the legs of the resistors, I'm going to put the legs onto that piece of tape so that I don't lose them in the carpet. My first resistor is going to feed from the positive rail on the left here into one of the rows, and it's going to go into row 28. So basically I'm going to just bend this pretty close to the body of the resistor. I'm just kind of ballparking it here. And it's going to go from positive rail into row 28. I'm going to go ahead and grab my wire cutters here and I'm going to clip these legs just a tiny bit. Then I'm going to take the legs that I clipped and put it into my tape so that I don't lose them in the carpet. So now when I put this into row 28, and also the positive rail, it's going to be nice and flat on the breadboard. Next up, I'm going to place an LED spanning the ravine, and we're going to do this basically by putting the longer leg, the anode, on the left side, and the shorter leg, the cathode, on the right side. It's all going to go into row 28 along with that resistor. I'm going to push this back a little bit so that maybe you can see where I'm talking about. See how the legs are in row 28, right in line with that resistor. And it kind of wants to stand back up of its own accord. I'm not going to clip the legs of the LED because I actually don't mind the LEDs standing up. And in a lot of projects, sometimes having the LEDs standing up makes it actually look a little more interactive because the LEDs are high and lighting up while the buttons and things like that will be low on the breadboard. Last, I need to connect this LED back to ground. I'm going to do that by using the negative rail. So I'm going to grab another wire here. And I'm going to run this from row 28 again into the negative rail. Now I'm ready to connect my Pi and see this LED turn on. Remember, you should always wear safety glasses when plugging in a new circuit for the first time. Keep your safety glasses on until you know that circuit is working correctly, and then you can safely remove them. The reason why we do this is we don't know if we've miswired something, and it's a great idea to always protect our eyes. Here's the ribbon coming off the Raspberry Pi. I'm just going to slide it into this top part here. It only really fits one way because there's a notch on the other side of this, and it only fits into the cobbler one way. So I'm going to press that down. And now that that's installed, I'm just going to plug in my Raspberry Pi. As I mentioned earlier, I took out the SD card, so it's just functioning sort of like a glorified battery. However, if you have the SD card, it will boot up, and you'll need to remember to shut it down properly. So I plugged in the Pi, and the LED lit up as expected. What we have here is a current path that comes out of the 3.3 volt pin, travels down the positive rail, through this resistor, into the LED, causing it to light up, then out of the LED into this path here that leads us to the negative rail, and the negative rail connects back to ground G and D pin over here. Before I add another LED, I need to unplug my Pi. Remember, don't build with your Pi plugged in. Only plug in the Pi whenever you're ready to test your circuit. Now I'm ready to move on to the next LED, however this time I'm going to put the resistor after the LED. Every time you put an LED into a project, you must use a resistor to protect that LED. So I'm going to put the wire first, and this wire is going to come off the positive rail and go into row 34. Next I'm going to grab my LED, and this is going to span the ravine just like the previous one. The anode, longer leg, is on the left hand side, and the cathode, the shorter leg, is on the right hand side. I'm going to push it back again, and maybe you can see, I know it's tiny in the video, but you see those legs there are in the same row as the wire, row 34. So the anode, longer leg on the left, cathode, shorter leg on the right. Now I need to put a resistor, but this time it's going to go after the LED on the right hand side. So this is going to connect me back to the negative rail. Again, I'm going to just bend the resistor and clip the legs. I'm just going to bend the resistor actually pretty close to the body of the resistor, because it happens to be just about the right width to make this circuit. So I've bent the resistor, and I'm just going to clip the legs, give myself just a little bit. I'd say this is maybe a little more than a 1/4 inch. And you have a lot of resistors, so if you make one too short or too long, you can always clip a fresh one. Again, I want to grab those legs of the resistor and press them into the tape so I don't lose them in the carpet. And now I'm going to install my resistor heading from row 34 into the negative rail. So now this second LED has a complete path, heading from the 3.3 volt pin down the positive rail, over into the row 34, up through the LED, out through the LED, into this resistor, which protects the LED, and now into the negative rail, which heads back to ground. I'm going to put on my safety glasses so that I can test the new circuit, and plug in my Pi. Here you can see both LEDs light up, and these LEDs are actually wired in what's called parallel. You can see they actually have similar looking paths. This would remind you of parallel lines going across the board here. I'm going to add one more LED, but as I've mentioned before, we don't want to build with the Pi plugged in, so I'm going to unplug the Pi now. This last LED I'm going to wire differently. In fact, this LED is going to be only on the left side of the ravine. The longer leg anode is going to be in row 39, and the shorter leg cathode is going to be in row 40. So I've inserted this LED, and you can see in the video here, the longer leg is in the top row, 39, and the lower leg is the shorter leg, the cathode, in row 40. Kind of slid this up a bit because I realized that it's actually kind of hard to see in the video. I'm going to grab another resistor here, and same deal as last time, I'm going to just bend it close to the body and clip it. This resistor is going to span from the positive rail into row 39. Now I need to connect this LED back to the negative rail, but since I didn't span the ravine, the negative rail is going to be the one on my left. So I'm going to grab a wire and connect row 40 back to the negative rail. Now this path is currently not connected to a G&D pin on the Pi. This negative rail on the left side is not connected to anything, so I need to connect the negative rail on the left to the G&D pin, which is actually in row 22 up here. So now I have a new path that's going to feed out from the 3.3 volt pin, down the positive rail, through this resistor into the LED, out of the resistor, into this little wire here that feeds to the negative rail, up the negative rail, and back into the G&D pin. However, it is very important that you make 100% sure that this G&D pin is connected to the negative rail and not to the positive rail. Notice, the positive rail is connected to 3.3 volt. If I put this wire in the wrong place, it would create a direct link between 3.3 volt and G&D. So it's extremely important. It's only one dot away. It's extremely important that you make sure that this is 100% in the right location. So I have the negative rail hooked to the G&D pin, and the positive rail is hooked to the 3.3 volt pin. And there is no direct link without passing through a resistor and LED between the 3.3 volt pin and a G&D pin. Ready? Let's plug in the Pi. As we would hope, all three LEDs are lit, and again, actually all three of these LEDs are wired in what's called parallel. Basically, it means that all these LEDs, if you actually could unwind the connections underneath, they have a parallel path from 3.3 volt passing through all three LEDs in parallel as it heads the current back to ground. Congratulations, you've officially built your first circuit.